Welcome to The Explainer. Today we're talking about something that's quietly derailing even the most exciting AI projects. A hidden price tag, a kind of ticking clock called technical debt. And I think this quote from a few Google researchers just absolutely nails it. They called machine learning the high-interest credit card of technical debt. It's the perfect way to think about it, right? You get these incredible results up front, you swipe the card, but that interest starts compounding in the background, and sooner or later that bill is going to come due. And look, this is not just some academic idea. A recent study from HFS Research shows this incredible paradox in action. A whopping 84% of companies are jumping into AI expecting it to save them a ton of money. But at the same time, almost half of them, 43%, are reporting that it's creating brand new kinds of technical debt. That's the conflict so many companies are getting caught in right now.
So that begs the question, what is this new kind of debt? And really, why is it such a different beast from the kind of problems software developers have been dealing with for years?
Well, this is where you see the fundamental shift. For years, tech debt meant things like messy code, maybe some outdated libraries, or just terrible documentation. But with ML, it's a whole new ballgame. The debt isn't just in the code anymore. It's living in your data, it's in models that slowly go out of date, it's in this wild concept called entanglement, and in all sorts of crazy configuration problems. Let's talk about entanglement, because it's probably the biggest monster under the bed here. In normal software, you try to build walls between different parts of your code. But in ML systems, everything is tangled together, like a giant ball of yarn. You pull on one little thread over here, change just one input feature, and it can cause this unpredictable, cascading chain reaction across the entire system.
And here's how that sneaky ripple effect actually plays out. It starts with something that seems totally innocent. Let's say one of your data sources changes its format. That tiny change deep inside the system silently starts shifting what the model thinks is important. And the next thing you know, the predictions your whole business is relying on are becoming unstable, and you might have no idea why.
Okay, so you can see how this happens. But let's look at how it all adds up to real, tangible costs. Costs that can blindside even the most seasoned tech leaders. We're really talking about a hidden maintenance tax that gets slapped on every AI investment. So get this, an empirical study found that ML projects rack up twice the amount of technical debt compared to traditional software projects. And the real kicker? This is self-admitted debt. This is the developers themselves saying, yep, we're taking shortcuts here at double the normal rate.
Which of course leads to the million-dollar or multi-million-dollar question for any CTO out there. If we're accumulating all this debt, where is the money actually going?
This is where the numbers get really eye-watering. HFS research found that the economics are often totally backward. For every $1 million a company spends on an AI software license, they should plan on spending another $2 to $7 million just on the services, the integration, and the constant maintenance to keep it running. That hidden tax isn't just a small fee, it's often way bigger than the initial price tag.
And if you look closer, this debt isn't spread out evenly. Oh no, it loves to cluster in the riskiest, most experimental parts of the process. Nearly half of it comes from just building the model itself. Another quarter comes from getting the data ready. These are the stages where you're under pressure to move fast and innovate, and that's exactly where these long-term problems take root.
All right, I know this all sounds a little doom and gloom, but it's not hopeless. There is absolutely a path forward. It's not about giving up on AI. It's about being smarter, thinking differently about the architecture you build on, and the way you actually operate these systems day to day.
First up, we have to rethink the very foundation. The antidote to these fragile, code-heavy systems is a more modular, component-based architecture. A great way to think about it is like building with Lego bricks instead of trying to carve a statue out of a single piece of stone. These modern platforms make integration a core part of the product, not some huge, expensive service project you have to tackle every single time.
The other half of the puzzle is a discipline you've probably heard about called ML Ops, or Machine Learning Operations. And really what ML Ops is all about is bringing some much-needed discipline and rigor from software engineering into the often chaotic, experimental world of data science. It's about turning the art of building a model into a repeatable, automated, and reliable engineering process.
And the great thing is, MLOps gives us a direct toolkit to fight back against these specific debt problems. Worried about instability from entanglement? You use strong version control for absolutely everything. Your data, your models, your code. Worried about your model getting worse over time? You set up real-time monitoring and automated retraining. Overwhelmed by complexity? You build modular, automated pipelines. It's all about building AI that can actually last.
So, when you boil it all down,
Building successful AI that lasts isn't about finding one magical algorithm. It's about building a solid, sustainable engineering practice. And believe me, this is going to be even more crucial when we look at what's coming next.
Because the future isn't a single all-knowing AI. The future is a team of AIs. We're moving away from one model trying to do everything and moving towards these complex systems where specialized AIs actually work together to solve problems. Microsoft Azure actually paints a really cool picture of this. Imagine a team of AIs trying to plan a new city park. You'd have one agent that's an expert on community feedback, another that analyzes the environmental impact, and a third that's crunching all the numbers on budget and maintenance costs. They would literally collaborate, almost like in a group chat, to come up with the best plan.
And this leads us to the final really big thought for today. If managing the technical debt of just one AI model is this hard, how on earth are we going to manage the complexity and the hidden debt of an entire team of AIs all working together? Answering that question is going to be the defining engineering challenge of the next decade.